Hi everyone, welcome to Coding Tutorial 3 Part B. My name is Everly. Um, in this class, we are going to teach you how to monitor your model's parameters, features, and gradients when you're training the model. So we're going to build a visualization tool, and after that, we can test the model with different initializations to see how the visualization goes. Um, so first we will copy the data set from part A tutorial, copy the model, and then we'll build a visualization tool. And after that, we'll do some changes to the model initialization and then visualize the parameters, the features, and gradients. All right, so let's start with creating a data set. Um, so here, let's just go back to part A data set. Again, this is the data we're running on. So let's run this cell and then define model. Let's just use the model that we built in the in the first part of this tutorial. Okay, run it again. And now we're going to run visualization. We're going to write a visualization class. And before that, we can also copy the model initialization and running epochs. Here we need to initialize loss, define a loss, and we need to define optimizer and then run the epochs. So here is how we initialize and run the model. Okay. So what we want to do here is that we can build a visualization class here and then update it when we run the epochs. And after all the epochs, we can plot the result. We'll come back to this later. And now I'd like to start with introducing some other packages that we haven't talked about before. So we've introduced a little bit of Seaborn before. So today the plot we're going to do is violin plot, and if you're interested, you can check out this documentation. So basically, the data is going to be a data frame. We'll talk about this data later. And as we visualize, what we want to do today is in this form. So we're going to plot a violin plot with the data we have, and then we will define the x-axis as different model layers, and then the y-axis would be the value of what we're plotting, the value of gradients, the value of parameters, and the value of the features. And we also need to define hue here for different epochs so that we can monitor how these values change, the distributions change over epochs. All right. So with that, let's come back and talk a little bit about data frame. So data frame is a data type from pandas. So import pandas. It is a little bit like a table, so we can demonstrate a little bit here with the data we are going to use in today's tutorial. Let's first define the columns of this table. we need different epochs. We need the layers, the name of the layer, and the value. That's the distribution we want to collect. Um, so let's make up some fake data here just to demonstrate what data frame looks like. So we need a couple rows here for epoch, layer, and value. So let's say we just run the first epoch. That's epoch 0, and the layer's name, for example, L1, and a random number. That's the value we collected. And again, L1, we might have other values. And then we might have different layers like L2, and then a random number. So something like this. This is what we'll collect, and we'll print out information later so you understand what's happening when we're going through the visualization. But now let's just take a look at what data frame should look like. Let's declare a data frame called df here and call data frame. That's the initialization. When we initialize it, we need the data and then the columns. All right, so now we have the data frame. A quick way to learn about this table is to do head, and that will print out the first 5 rows of this table. Okay, so this is our table now. Our data is going to look something like this later. All right, with that, let's move on to building the visualization class. So for visualization, we can name it a class that's called visualization helper, and then we have to first start with initializing this class. For initialization, we need a couple data frames here to store the data that we're collecting. So again, let's start with the columns. And then we need gradients, and that's the data frame. We can create a data frame without data, so that'll be empty, but we can still define the columns. All right, so we're going to do parameters, and the features include the values of z, and that's before activation. And after activation, let's just call it activations. Okay, so these are all the data that we want to plot, and we can put them in the in self, so we can call them later. And so for each epoch, we can update the values. So what we need here is the model state and the epoch number. Okay, let's start with collecting the parameters and gradients. And you can find those in named parameters. So if we call this, um, you can go here to check out named parameters and how it's used. So uh, basically what we do here is that it returns the name of the parameter and the parameter themselves. And so let's print the information here. Here's the name. And to grab the values of the parameters, we can do data. And then to grab the gradients, we can do grad. Okay, so before proceeding, let's check, let's run update. Oh, we haven't initialized it. Okay, so let's create an visualization tool here. And then we can do visualization and call update values. And then here we can input the model and the epoch. All right, let's run this cell and then run this. Okay, so this is what we got, the return we got. Let's not print this. Okay, so the name, we first print the name and then data and then grad. So here's the name of that layer, of that parameters, and then we have the parameter data itself, and then the gradient itself, and they're all in tensor. So we're going to utilize these data later. So let's do numpy so that it's an array. And run this again. Okay, so now these are arrays. And the shape is 5 to 3 now. We can print the shape. Okay, so the bias shape is 3 and weight shape is 5 to 3. So that is for that layer. We have this many um, values. So we're going to collect all those values and put those into a distribution. And to do that, we can do Ravel. That is for flattening. Okay, we don't need to print out this. This is the data we're going to use later. So with that, let's do the gradients first. So the gradients will be this. Sorry, this is the gradients. So for each value um, in the flattened array, we need to store, remember the data is epoch, layer, and value. So let's first have epoch, and then the layer would be this name that we printed out, the name, and then the value. Okay, so this is the data we want to use, and then we can make it into a data frame. And don't forget the columns. Okay, so this is the gradients we got from this from this epoch. And oh, I'm sorry, for each layer, this is the gradients we get. And to update the all the big data frame here, we can do to concatenate two data frames and the new data, and ignore index for simplicity. Okay, now so now we have all the gradients stored in self gradients, and we can do the same for um, data, which is the parameters. So let's do here data, and this would be parameters. And again, put that into self parameters, concatenate. Okay, so now we have all this um, data collected from gradients and parameters. Let's move on to the features. So the features is actually here in forward. So when we're calculating forward for the model, we have, for example, if we're looking for the z values after the first linear, this is the values. And then this is input to activation function. So act one here would be the value after the first activation function, the features after the first activation function we want to collect. So in order to grab this data, a quick way to do this is to um, define features here. We can do the z values, and this is just initialization. So activation. Okay, and with this, we can, for every forward, we can grab the values. Okay, let's do a dictionary here so it's clearer. Right, so for this, the z values dictionary, we can have linear 1 and linear 2. And for activations, we can have activation 1 and the output, that's activation 2. All right. update features. Okay, so this would be the new class. So here, if we want to grab that, we can just do the model and then get z values. That's a dictionary. So let's say we do this, the name again, and the values. Okay, so we want the data frame. We want the data frame to be this in the same format. So let's do z values be a data frame, and then for all the values, we again collect the epoch, the name, and the value. And it's a tensor, so we can do detach and then transfer it to an array. And again, we need to flatten. All right, so that's the data, and columns will be the same columns. Okay, so this is the z values, and we need to do the same thing here for concatenation. So z values. All right, so now using this for loop, we grab the z values, and let's do exactly the same thing for activation functions. So just change it to activations. Then, all right. So this should be all good to go now. We have collected 4 different data frames: the gradients, the parameters, z values, and activations. So one last thing to do is to plot everything and define the figure size. So I will just use 12 to 5 now, but you can change that um, in this when you call this function. So, so for a volume plot, we can do PLT figure and then with the size. And call Seaborn violin plot, and then input the data, say the gradients, and then following this x, y, and hue. So we can do x will be the layers, and y will be the distribution of all these values we collected. and we can set hue for different epochs. And then this plot can have a title and show. Okay, so now we already have update values for every epoch. One last thing to do is to plot. Okay, run this class that we built for visualization. Then run this. Uh, okay, I typed everything wrong. Oh, just these two. Okay, so do this. Okay, too many epochs. Let's do 5. Okay, here is what we got. We have these layers with linear 1 weight and bias, linear 2 weight and bias. Okay, so this is the gradient we have. For gradient and parameters, we can just visualize the weights. So alright, run this again, then run this. Okay, so now we only have the linear 1 weight and linear 2 weight. So this is the plot we want. And since we have 4 plots to do, we can simply create a for loop. Let's have plot names as gradient and parameters, and then z values, and finally activation, and then the data will be gradients, parameters, z values, and activations. So for the name and data in the zip of names and data, we can run this. Alright, the data will be data, the name, the title will be name. Alright, run this, and then let's do this again. Okay, so now we have 4 plots here. The first plot is gradient, second plot parameters, third plot z values, and the final plot is activations. So through this visualization, we can visualize these values in distribution to monitor how the model is doing, to see if the model is actually learning, if the gradient, if the parameters are supporting the learning. So one last thing to do. So let's try a little bit of extreme initializations to see how these plots will be like. And to do that, we need to go back to the model. So we can do this and then init. This supports initialization. And what we're using here today is the uniform distribution. So initialization, and that will be um, we need to input a value here. So if this is not none, then we initialize the model. If it's none, it's default. That's the model we just ran. Um, so nn init and then call uniform, and we will do start with the first layer and the weight, and then it needs the bound. So init value, we can input two numbers. A would be the first, then B will be the second. And we can initialize the bias the same way. And we can do the second layer, linear 2, the same way. All right, this is all of the parameters we're initializing. So with that, we can return here to when we built the model. The value can be 0 and 0. So if we do 0, 0, all the parameters are going to be initialized as 0. So don't remember to run everything updated. Okay, so if we run it this way, we can see that for gradient, it's all 0 because there is no gradient. And the parameters are 0. These are the z values and after activations. So basically the model is just not learning at all. So to make this easier for you to compare, let's wrap this into just coarsely wrap it into a function. Run training, and then we can assign this init value, and then do init value. Okay, so now let's run this with a default initialization. So the init value would be none. Okay, it looks like the model is learning normally. It's learning fine. And for the next one, let's try zeros. That's what we just did. So the model is not learning at all. And then finally, we can also try initializing with very large weights to experience vanishing gradients, say 100. So what we learned in lecture about vanishing gradients, if we have very large parameters here, from about 100 to 200, then because the function that we apply is sigmoid, so that means basically the model is barely learning. So the gradient is vanishing because the initialization is too large. And that's all for today's tutorial. I encourage you to play with this visualization code base that I provided. With like different settings, you can change the model a little bit. You can build more layers to this model to see what happens. You can train for more epochs, and I leave the figure size here for you to plot different size. You can add it right here. If you have many epochs, you might want to change that. So yeah, that's all. Try different initializations. Try changing the activation functions. Experience what it is like to have all the gradients and parameters printed out in plots as distribution, so that uh, you can learn more about your model. Yeah, that's all for today's tutorial. Feel free to stop my office hours if you have any questions, and don't hesitate to reach out to me. And that's all. See you next time.